Negative 1. What's 1 times cosine of power 2? 0. I love zeros. And what is, well, that's just a what? 1. So I gotta put a 1. Now let's see what I did. I just thought it'd be easier. Let's cross this. We can do this because it's at a specific point. It's at that precise point. So plug in the points for like it's easier. Then we'll get the cross product. We'll get the normal vector. So cross those. What do you get? What is that cross product? Those vectors. Let's see. Let's RU cross RV. You know how to do this. 3 components. Here, wipe out the first column.
So 1
that times that one is that times that.
1.
What?
You gotta change the sign, right?
Change the sign for the middle component. And what's 0 times 1 minus 0 times negative 1?
0.
Or negative 0. And what's the last component? 0 minus negative 1 is?
No, yeah, positive 1.
Positive 1. So what's the final answer? Here we go. Remember how to do this? We put the coefficients to x minus the point, y minus the value, z minus the value, and we set the whole thing equal to what? 0. This is the equation of a tangent plane. What's the normal vector? 1, 0, negative 1. And what was the point? Remember we found the point earlier? The point is 0, 1.
Shouldn't that be positive 1?
Let's see, did I miss one?
The coefficient of the z component.
The z component is a positive 1. Oh, thank you. Thank you very much. I understand that was a 1 right there. It's a positive 1. That's the equation of the plane. This is the equation of the plane. You want to simplify it? What would that simplify to? I'll put or. This would be x plus 0 plus
z minus pi.
That's the equation of the plane?
That should be z, Professor.
And that last one's just the z, right? There we go. X plus z minus pi over 2 equals 0, or x plus z equals pi over 2. Equation of that tangent plane. To that helicoid at this point. Isn't that cool? Awesome. Well, now let's find surface area. So that was the equation of a plane tangent to a surface. How about the surface area? Now we're talking about we're going to get the double integral of the magnitude of the cross product. And if you recall, everyone, that right there was the area of a parallelogram. And that's why this formula is derived by that, by just using patches. These patches along a surface. An infinite amount of these patches that are parallelograms. Let's try one of these. And we're going to use that same practice sheet right here. Let's try this. I'll write it on the board. Everyone, can you find the surface area, the part of the surface? So we're going to find surface area. It's funny, in Calc 2 we did surface area. In a Calc 2 class, but that surface area always got revolved about an x-axis. This is just finding the surface area. Straight out, we don't have to have this revolved anywhere. The surface is z equal to xy, nothing crazy. That lies within the cylinder. So when you do not have to draw this. When Art, earlier you were talking about polar coordinates. And when we're going to be doing a double integral here. If it's lying within a cylinder, you will agree we should eventually go polar. Yes, just because of that. Find just surface area disk that lies within the cylinder, within a disk. We'll project a disk. That's what we'll do. Sound good? Alright. So, let's get started. First thing, I need what? Hardest part of the problem. Right there. This is the challenge for today, everyone. Or this is the challenge for the rest of our course, 16.6 to 69. You will crush this stuff, but where we can get lost is, where are these R's? You see it? Look at problem, I don't see an R anywhere. You on your own have to parameterize the surface. Someone got that? And once you got that down, I think it'll be easy rolling. Because you know how to do partial derivatives and stuff, right? We'll just follow all the step-by-step procedures to get that double integral solved. But here's the challenge. I need you to parameterize the surface. And something else confusing. Which surface is the one you're getting the surface area of? What do we get in the surface area of? And just I'll let you read the question. Find the surface area is equals x, y that lies within the cylinder. We're parameterizing which surface? That one. Cool. Because that's the surface that we're getting the surface area of. So you want to use x and y? Yeah, alright. Let x equal x, let y equal y. Not too hard. That's an x, that's a y, and what goes right there?
X, Y.
That's the challenge. That's the hardest part to these problems. And I hope you found that easy. That you go, oh, once I do that, I'm rolling. So you don't have to use U's and V's, do you? That's the idea. They're just, that's a template. That's a template. Many times you'll use x and y. Okay. So, we do have to get r sub x, r sub y, then cross them, get the magnitude, and set up the double integral that projects over that cylinder. So we got a little work to do, but we'll get it done. Ready? What's r? So that's the hard part. You're done. Check. Well, what's r sub x? Watch you fly. What's that derivative? What's that partial derivative though? Y. Good. R. What's r sub y? Zero. One and. And you all look awesome. These are two tangent vectors in the plane. You cross them, you're going to get the normal vector. Good job, everyone. All right, go ahead and cross these. Here, wipe out the first column. 0 times x minus y times 1. You get what? Middle component, change the
Sign.
sign. All right, you want to change the sign in the middle component. Let me leave a little space there to do that. What is, let me wipe out the middle column. Boop. 1 times x minus y times 0.
X.
So negative x. And what's this last component? 1 times 1 times 0
One.
times. Now, can you stare at this real quick? Oh, silly. Oh, so this right here, that first one, right? Yeah, she's right. I'm going to put it right here. See, Hilly, thank you so much. That first component there, when she's saying I should have had a negative y, because when I wiped this out, I said 0 times x subtract y times 1. So thank you so much. And the middle component's negative also, right? Because we said negative, then we did this times this, minus this times this. Cool. And when would you stare at this? This is a normal vector. The z component is a positive 1. Is that going upward or downward? So I just want to point out, you have this normal vector is upward. It's not so important with our problem right now. It's going to be important coming up soon. Because they're going to talk about, we're going to find a flux tomorrow's lesson. During tomorrow's lesson, we're going to find something called a flux across the surface. And they're going to give you the orientation. Either upward orientation or talking about all the normal vectors to the surface. So if they say upward, we're going to be fine here. But who knows what you got to do if they say you're using downward orientation. Because you need a normal vector. You just point this in which direction? The opposite. Now how do you do that? Just flip the signs. Very good. Someone got that? So it's not important now, don't worry. But tomorrow when they go, hey, it's oriented upward, or they say oriented downward, they're talking about the normal vectors to the surface. So your eyes are stare at that. And you'll make sure, if they want upward orientation, you're going to make sure all the normal vectors across the surface are pointed what? Upward. Because that's what it's doing now. When these are just what? This is giving you the normal vectors to the surface. It's, oh, they're all upward. Yeah. So they go, what if they say downward orientation? Oh, just change all the signs, right? Still a normal vector. That would, by the way, that would be ry cross rx, wouldn't it be? Someone agree? Now I'll just put it over here. What's ry cross rx? You do not have to do all the math right now. We just simply do what? Y, x, and a 1. Ta-da! So keep that in mind. It's just the key to tomorrow. Now, do I put this in a double integral or I can do something first? Yeah, we need the magnitude. So what's the magnitude of the theta? Square root squared plus that squared plus 1.
1, yeah.
What's that squared?
Y squared.
Good. A negative squared is a positive. Plus, what's that squared?
X squared.
X squared. And when a negative x squared is a positive x squared.
Plus 1.
And what's a 1 squared?
1.
There you go. And all I gotta do is put this in a double integral, right? I've got enough room right here to do this problem. We'll just do it right here in this nice little column. So here goes. This will be my surface area. You know what is it? It's the double integral. I'm just going to call this d right now. Square root of y squared plus x squared plus 1 dA. I'll let you choose whether or not you want to do dy or dx, or if you want to go polar. But this is the start to our problem. Now, what's d? How much of the surface are you projecting that to get the surface area? Only within the what? Oh, so now the cylinder comes into play. What's the radius of that cylinder?
1.
And a projection would be a circle, right? So we're all thinking go polar. So I'm just going to draw a little miniature circle here for d. Because it's got to be inside that cylinder. We're like, oh, okay, that would be projected with a nice radius of a 1, right? Make a better circle than that. I'm going to shade it in like it's a disk. X squared plus y squared, always less than or equal to 1. But everyone, I think you all agree, let's go what? We knew it was coming. Let's go polar. Because that's a disk. So I'm going polar. Before I forget, what letter? I'll put it, because I don't want to forget it. Already theta, right? Okay. Keep that square root. What can you make this? Way to go. R squared plus 1. What's theta? They said the full cylinder lies with 0 to what? What's the radius?
1.
0 to 1. That's way better than going Cartesian. 0 to 2 pi, 0 to 1, r squared plus 1. Now, how do you do this integral? And can I break up the integral if I want? Can I split it up?
Yes.
Good. I got 4 numbers, and I can rewrite this as r's and theta. So I am going to break it up. So we can quickly get rid of the 0 to 2 pi and the d theta. What's the integral of 0 to 2 pi to 2 theta? 2 pi. But one right here, you're going to have to do a u sub r. I got enough room right here. We've got plenty of room. What's u equal to?
Square root of r squared plus 1.
Ooh, he says just let u equal the r squared of 1. So what's du?
2r.
2r dr. So what's 1/2 du equal to?
R dr.
R dr. And I can do this integral. Everyone care with this u sub? Nice. Let's go in here. Boom. You're gone. Boom. You're gone. We got the integral 1/2 integral radical u du. And I'll multiply that 2 pi. So don't forget about that little half, right? What's the integral of a u with the radical in it? That's u to the 1/2.
2/3.
So I got a 1/2. U to the 3/2 multiply a 2/3. You still got this what? 2 pi. And anything cancel? And there's 2's do. So I get 2 pi times 1/3 times. And what I'm going to resubstitute to u. And I'll go from 0 to 1. What was u? So what's the final answer? 2 pi over 3? Plug in a 1 in there. What do you get? 1 plus 1 is 2 to the 3/2 minus, why don't you plug a 0 in there?
1.
There's my answer. That's the surface area. What do y'all think? I still think. I'll get away, some of you still copy it. This is the biggest challenge. You can sit there just going, what do I do in this problem? How do I get this started? I need to parameterize the surface we're talking about. And be careful on like practice set, problem set, test. Which surface are you parameterizing, right? You start getting lost parameterizing the cylinder, it can get all crazy. Don't okay with that? I love it. Well, let's do a plane. So, does anyone see that next? What's the one that says plane? What's the plane? Find the surface area of the part of the plane 4x plus 2y plus z equals 8. That plane's going to go on forever. So notice they say that lies in the first octave. Well, last time we didn't draw a picture. Let's definitely draw a picture of this one. Find the surface area, the part of that plane that lies in the first octave. Let's draw this picture. Do you remember how to draw a plane? Yeah. Let's do the intercepts. What's the z-intercept? Set x and y to 0.
8.
Here's 0, 8. Alright. Find the y-intercept.
4.
4. And now find the x-intercept.
2.
2. Up. Everyone, they want the surface area of this triangle right here. They want this area. Now you might be thinking, gosh, I could just do a geometry problem. Area of a triangle is 1/2 base height, right? Well, the tough part is how you can get that altitude, because it's got to lie right on that face, right? No worries, we'll just use this. So find the surface area of this part of the plane that's lying in the first octave. We'll just do the magnitude of the cross product of the tangential vectors. So we're not going polar on this, are we? But notice that is your projection. If everyone's okay if we project just onto the xy plane? Sounds good. Okay. So here's the biggest challenge.